Now let's talk about approximating things. So all of the problems that we will do this semester will be an approximation of reality. We will use models to show how things work in order to compute our desired result. For more effects, we will include the more corrections as we go along. For example, when we are talking about a moving car with people, the people in the car might be drinking soda or drinking tea or something or the other, or they could be talking. Physics is not concerned about what the people are doing inside. What we consider the whole system to be as one particle, an object whose all parts move in exactly the same way. Right? So in order to approximate more complex problems, we eliminate all possible internal motions. We just call it one particle moving down the line, and it makes our life easier. So a really good example that we can look at is we can approximate the number of cells in the human body. So average size cells in a human body are about 10 micrometers in length. How many cells are there in the human body? Make an order of magnitude estimation. It's a very good example when we're talking about the human body. So this may seem like a very daunting task, but we can do an order of magnitude estimate. So first of all, we are required to find the number of cells in a human body. And it says that the length of each cell is about, so the length of each cell is about 10 micrometers, which we know is about 10 to the minus 6 meters. Okay, even though this is a very daunting task, we can subdivide this problem into 3 parts. First, we can estimate the volume of a human, then we can estimate the volume of an average cell, and then we can estimate the number of cells, which makes our problem a little bit less daunting to handle. Okay, so first of all, let's start with estimating the volume of a human. Okay, so step 1. What is the volume of a human? So, a human, most of us, sort of kind of look like this. Okay? In physics, we will approximate this human to have this shape. Okay? That means we can use a volume of a cylinder in order to figure out what this human's volume is. The volume of a cylinder is given by pi r squared h. Okay, so for an average human, let's suppose that his height is about 2 meters and his waist is about 27 inches, and we convert that 27 inches to meters, and we can approximately say that his waist is about 1 meter, right? So his radius is about 1 meter. I'm sorry, his circumference is about 1 meter. Ooh, radius 1 meter, that's going to be a huge human. No. Let's call it circumference. Circumference is about 1 meter, right? The relationship between a circumference and a radius is 2 pi r. So in order to calculate what the radius of a human being could be, we could just plug in 1 meter here, divided by 2 pi will give us an r. Okay? Plug all of those values into our volume equation, and what do we get? We get a pi and r, which is about 1 over 2 pi radius, times a height of a human is about 2 meters. Okay? Do a quick calculation, and we can approximately say that our human is about, give or take a few numbers, it's about 0.06 meter cubed. Now for step 2, let's estimate the average cells. like we can calculate the volume of average cells. Okay? We can do it two ways. Let's first start by assuming that our cells are cubes, right? If our cells are cubed, we know that the volume of a cube is equals to length cubed. Okay? Given his length is 10 to the power minus 6 meters, I can approximate this as 10 times 10 to the minus 6 meters cubed, which comes out something like 1 times 10 to the minus 15 meter cubed. Now step 3 is, in order to find the number of cells, we are going to find the volume of the human body, divided by the volume of the average cells. Okay? Which means we could do 0.06 meter cubed divided by 1.1 times 10 to the 15 meter cubed. Meter cubes and meter cubed get canceled, and I get approximately 6 times 10 to the 13 as my answer. Okay. Now, another approximation, someone says, well, our cells don't look like this, right? They're actually round and they're spherical. Perfect explanation, okay? Now let's look at what happens if you have, instead of circle, you assume it to be a sphere. Well, volume of a sphere is 4/3 pi r cubed. So in order to for us to calculate what that answer is going to be, plug in 10 to the minus 6 meters into this formula, and you can solve for it and come up with approximately 4.18 times 10 to the minus 15 meters cubed, right? Approximately. And when you take a sphere and you plug it into the volume, what you are going to find is that the number of cells in this case will equal approximately 3.82 times 10 to the 13. Compare these two numbers. Order of magnitude calculations, about a good number to have. Okay? So this is a very good way of estimating the number of cells. Yes, some people may have slightly more or slightly less, but it's an order of magnitude calculation. Estimate the number of time a human heart beats during its lifetime. Now, this is a very daunting test as well, but in this case, we can make it easier if we use approximation. So the first approximation that I'm going to use is, in general, all human hearts beat 1 beat per second. Okay, so that's my first assumption, approximation. 1 beat per second. I'm talking about a healthy heart that's not doing exercise, but over the lifetime, it's just beating 1 beat per second. Okay? And I'm also going to assume that my healthy human life lives up to a ripe old age of 75 years. Okay? Now, how do I solve for how many times his heart beats during the course of 75 years? Okay, so let's start at the beginning. So he lives for 75 years and his heart beats 1 beat per second, which means that his heart is going to beat 60 times a minute. Okay? So, 60 times per minute, right? 1 minute minute is equals to 60 seconds. I also know there are 60 minutes in 1 hour, right? And there are 24 hours in 1 day. And there are 365 days in 1 year. And he lives for 75 years in 1 lifetime. Okay, so now watch. Minutes go away, hours go away, days go away, years go away. What am I left with? Times per lifetime. So this means I have 60 times 60 times 24 times 365 times 75 beats per lifetime. Okay? So a quick calculations with a calculator will be able to prove to you what exactly that number is. So I am going to leave that up to you to fill in the blank. This is how many times his heart beats per lifetime.